Welcome to Scaling Up H2O, the Industrial Water Treaters podcast, the podcast where we're scaling up on knowledge so we don't scale up our systems. Hello, Scale It Up Nation. Trace Blackmore, CWT here. That means Certified Water Technologist, the highest designation that somebody in my field of industrial water treatment can achieve. And I am coming to you right here from the Lawrenceville, Georgia. Where the heck is Lawrenceville, Georgia? Well, it's right outside of Atlanta. Coming to you from our studios, and I am answering more questions that you all have written in to me for me to answer. And the one I'm going to answer today is actually one I'm pretty sure I've answered before, but maybe I didn't do a good enough job with it, or maybe it was too early in the series and not everybody heard it, but I received several questions around what the heck alkalinity is. And I figured since we're talking about pH and other episodes, we may as well talk about alkalinity because that goes right along with it. If you have not listened to the pH episode, I urge you to go back and listen to the episode where I just talk about pH. I think the explanation of alkalinity goes very well once that explanation has been given. So your homework, if you're listening to this show right now, and as I'm recording it, I do not have the actual show number, so I can't do that to you, but it's really easy. Go to the website and look for the pinks and blues on pH. If you're on your favorite podcast app, you can just scroll through all the episodes and find the pinks and blues for pH. That being said, I'm going to assume everybody has listened to that. And everybody knows that the pH scale goes from 0 all the way up to 14. And by listening to that show, you know why that is. Now what we're going to do is we are going to talk about alkalinity. Now, when it comes to alkalinity, alkalinity is so very important to our water treatment programs because our programs are designed on the type of alkalinity that we have in our waters. And a lot of times when I'm working with other water treaters or other companies that have some sort of problem, normally pitting, it's because they're using the wrong chemistry for the alkalinity that they have in their water. So it's very important that us water treatment folk understand exactly what alkalinity is. And I'm going to try to do this visually because I'm a very visual learner. But as you are probably figuring out, a podcast is a horrible way to visually teach somebody. So here's what I need everybody out there listening to the Scaling Up Nation to do. I need you in your mind's eye to picture a vertical graph where the very bottom is 0 and the very top of that graph is 14. And of course, we know that that is the pH scale. So we're going to work from the bottom of that scale up, and I'm going to explain which alkalinities exist at different pHs. All right, working from the bottom to the top, we're going to go to a 4.3. Now from the range 4.3 to 8.3 pH, that is where bicarbonate alkalinity exists. You might also hear that called M alkalinity. All right, so hopefully everybody has that visual. Now we're going to go to 8.3. From 8.3 to around 10.3, these numbers are all ish, as most water treatment numbers are. That's where carbonate alkalinity exists. We might hear that called P alkalinity. If there's one thing that we have in water treatment, it's multiple terms. And I know that's really difficult for somebody learning because we'll learn something one way and then we'll be introduced to another term. Well, folks, just get used to it. We have multiple terms for everything in water treatment. I don't know why that is, but that is how it is. All right, so now we go to 10.3 and above. Above 10.3-ish, we have hydroxyl alkalinity. So those are the 3 alkalinity species that we have, and then our water treatment products are built based on that. Now, from the pH show, you know that a chef needs 5 ingredients in order to make scale, and those were calcium hardness, alkalinity. Hey, here you go. We're talking about alkalinity, pH, total dissolved solids, and temperature. So that's why alkalinity is so important, because it actually combines with our calcium hardness to create that scale, specifically calcium carbonate, which is the water treater's nemesis. It is the hardest thing for us to control because we are water treaters that deal with transferring heat from one place to another. And calcium carbonate wants to come out of solution in warmer temperatures. Well, hey, that's no fun. Well, water treatment has things that are stacked against us everywhere we look. Why should that be any different? All right, so one more time. So we have bicarbonate alkalinity that exists between 4.3 and 8.3. Between 8.3 and 10.3, we have carbonate alkalinity. And above 10.3, we have hydroxyl alkalinity. And if you can think back to some of your service reports, like boilers, you probably had an OH alkalinity that you had to write down. And the reason that we have OH alkalinity in the boiler, and I'm not going to get too deep into this, but we need to make hydroxyapatite and not calcium phosphate. Calcium phosphate, I remember when I was younger, my father took a sample of calcium phosphate and he threw it against a concrete wall and it dented the concrete wall. Folks, this stuff is really hard to get rid of. It can be created very quickly, but it takes forever to get rid of it. One of the insurance policies that we have in a boiler, so we don't create that in a phosphate program, is we have extra free hydroxyls in the boiler water to make sure that we create that hydroxyapatite. And I know that's a really strange word, but just remember this: calcium phosphate, hard and will crack concrete walls. Hydroxyapatite, nice fluffy snow. And we have that nice fluffy snow that goes down to the bottom of the boiler. It doesn't really stick to each other. And then we have some sludge conditioners in there to prevent it from doing that. And we can get that out through normal blowdown. Calcium phosphate, we have to get out through some very difficult means. So that's why you want the OH alkalinity in the boiler. Now, a lot of you might have a test. There's a barium test that you test directly for hydroxyl alkalinity, but a lot of us do 2P minus M. Now, remember at the top of the show, I said we have multiple terms for everything in water treatment. Well, let me share some other ones with you. Now, I use the terms carbonate and bicarbonate alkalinity. Bi in this case means hydrogen. So we have hydrogen in one, we don't in the other. So with carbonate alkalinity, the reagent that you use to test for that is phenolphthalein. Phenolphthalein is a reagent that will only turn pink at a pH of 8.3 or above. Well, let's look at that. I said that carbonate alkalinity only exists at a pH of 8.3 or above. So how cool is we have a pH sensitive dye that we can measure the pH, and that tells us how much carbonate alkalinity we have. And the reason it's also called P alkalinity, it's named after the reagent. And if you're wondering what's going on with that, we have specific amounts of sulfuric acid that we use as the titrant. And we know that however many drops, they've been QC'd, that however many drops that we use will correlate to how much carbonate alkalinity that we have. All right, so let's move down the scale, and now we're at 8.3 to 4.3. Well, that's our bicarbonate alkalinity. And bi is our big fancy chemistry term that just means hydrogen. Well, that is between 8.3 and 4.3, and we might also call that M alkalinity. That M comes from an older reagent, one that our fathers might have been using, or my father did use, and it was methyl orange. And it wasn't a great color change. I think it went from like a red orange to a yellow orange. It wasn't a very definite one. So like everything, things evolve, things get better, and now we use bromol cresol green, which will be green at a 8.3 or anything above 4.3 actually. And we titrate that down to 4.3, and at 4.3, that green solution turns to red. And folks, it's really easy to see green and red, so that's why we use bromol cresol green. But we don't call it B alkalinity. We still call bicarbonate alkalinity M alkalinity, I guess because we're honoring the methyl orange. Now you might be wondering what happens below 4.3. Well, folks, that's where we have the absence of alkalinity, and that's where carbonic acid is. So now looking at boilers, especially condensate lines, if you get a pH below 4.3, you've got carbonic acid. And if you've ever seen a condensate line that has been attacked with carbonic acid, it looks like an inchworm has just plowed its way through the bottom. And it's always going to be at the bottom of the pipe because that's where the water is. That's where the condensate is. You would never see this on the top or anywhere else on the pipe. It's always going to be at the bottom. Now, what do we do to make sure we don't have carbonic acid in the water or in the condensate? Well, we put something that goes over with the steam to increase the pH. Why do we increase the pH? Because we can't have carbonic acid over particular pHs, and most of our systems are at 8.3, so we even get the bicarbonate alkalinity out, so we don't have enough free alkalinity in there to actually convert to carbonic acid in the presence of carbon dioxide. So I hope alkalinity makes a little bit more sense to you. I'm going to have a slide on my show notes page. I'm hoping that you visualize this pH scale, and now you know at where bicarbonate alkalinity exists, where carbonate alkalinity exists, and where hydroxyl alkalinity exists. And folks, I said at the beginning of the show that a lot of water treaters don't understand alkalinity, and it's so important because if you use a chemistry that was built for bicarbonate alkalinity, and you use it in the carbonate alkalinity realm, you are not going to get the right type of protection. Vice versa, you might get some disastrous scaling. You have to know what you're dealing with, and it's so important that you understand your product data sheets because they normally have a range of what you need to keep your chemistries within when it comes to water. That is the reason for that. Somebody's already done all the legwork for you and said if you stay between this and this pH and this hardness and this alkalinity, this product's going to work fine. But if you get out of that range, that product was not designed to work in those ranges that your water now is in, and you are going to have some issues. Well, folks, I think I've told you I am humbled to know that we are 10,000 subscribers and in over 60 different countries. That is amazing to me. And the reason that we have such a large scaling up population is because of the people in the scaling up population. Thank you so much, nation, for spreading the word, but the word is not done. I talk to water treaters on a regular basis that have never heard of scaling up H2O. We all know that we do need that little extra nudge out there, especially when we're by ourselves, driving from account to account. It's so great to be able to turn on your favorite podcast provider and hear some motivation or hear something that we can learn about our craft in between accounts. Well, folks, we need to raise the entire water treatment community. And in order for me to do that, I need your help. If you run into another fellow water treater, make sure you discuss scaling up H2O. I want to make sure that we have as many listeners as we can. That does a couple of things. One, it ensures that my show has an audience. Thank you so much for listening. It also ensures that the information that we're getting is coming from a large sampling of the water treatment community. I love getting questions from the Scaling Up Nation because that ensures that I always have something to talk about. And folks, if we didn't have that, eventually I'm going to run out of things to say. So please don't allow that to happen. Let your fellow water treaters know about Scaling Up H2O. And some of them, you might even have to show them how to subscribe to it on their smartphones. Not everybody has the familiarity with podcasts, and they might need a little help. The last thing I'm going to ask for you to do is to keep those questions coming. Again, this show came completely from questions from the Scaling Up Nation. I've got to replenish that bank. So go to scalinguph2o.com and let me know what questions you have, or if you have a guest that you want me to interview, let me know that too. Anything that you want to hear on the show, I need to hear from you. Please don't keep that information to yourself. It doesn't do anybody any good. So go to scalinguph2o.com and let me know what you're thinking. Nation, thank you so much for being the audience of this show. I can't tell you how much I enjoy bringing this show to you each and every week. Thank you for all the people that let me know that they really enjoyed listening to this show. That means so much to me, and I look forward to speaking with you next week on Scaling Up H2O.